Okay, so this problem reads, a rotating space station is said to create artificial gravity, a loosely defined term used for an acceleration that would be crudely similar to gravity. The outer wall of the rotating space station would become a floor for the astronauts, and centripetal acceleration supplied by the floor would allow astronauts to exercise and maintain muscle and bone strength more naturally than in non-rotating space environments. If the space station is 200 meters in diameter, what angular velocity would produce an artificial gravity of 9.8 meters per second squared at the rim? We have two equations that look at centripetal acceleration. We have the speed squared, and that's the linear velocity, the linear speed at the rim, divided by the radius, and we have a relationship for centripetal acceleration that relates the angular speed squared times the radius. So we're given that the diameter of this space station is equal to 200 meters, which tells us that the radius is equal to 100 meters. And we want to know what is the angular velocity, that omega squared, if that acceleration is producing an artificial gravity of 9.8 meters per second. So if the centripetal acceleration was equal to 9.8 meters per second squared. So I'm going to use this equation because I'm interested in that rotational speed. So we have 9.8 meters per second squared. Oh, I don't want to put in the units. So 9.8 equals omega squared times the radius of 100, and I get an omega equal to 0.31 radians per second. So pretty straightforward, just recognizing that acceleration we're referring to as a centripetal acceleration, and we're going to use the relationship that allows us to get right at that angular velocity right away. All right, good job.